Volume of prisms and cylinders. Volume is the amount of space that is occupied by a three-dimensional figure. It also references the number of cubic units needed to fill a 3D figure, such as layering, or you could think of if you're trying to fill a cup with water. You're filling it with cubic units of measurement. So when we find the solution to volume problems, we label our solutions as units to the third power, or units cubed, or we write out cubic units. When calculating the volume of prisms and cylinders, you multiply the area of the base and the height of the solid together, or V for volume is equal to capital B times H, where capital B represents the area of the base. And the area formulas that we'll be working with are the area of a rectangle, which is length times width, or base times height. Note that this height that's down here is not the same as this height of the solid up here. So it'll be helpful to label different measurements in the diagram using subscripts when needed. Similarly with a triangle, if you have a triangular prism, you would calculate the area of the triangular base first, which is 1/2 base times height, and then you would multiply the area of this base times the height of the solid. And then for a circle, or if you have a cylinder, you have pi times the radius squared is the area of the circular base. So really for a cylinder, if you wanted to, you could simplify that volume equation to be pi r squared times the height of the cylinder, because they will always be the same. So this is r and this is h. So you can write the volume again of a cylinder as pi r squared times h. And if you wanted to, because with a rectangular prism, its area is length times width, you could take length times width and replace the capital B here to write the formula as length times width times height, where you have the length here, width here, and height here. Find the volume of the rectangular prism. Well, we know that the volume of any prism is equal to area of the base times the height. Well, we know that in this problem, the area of our base is equal to length times width, because our base is a rectangle. So if we take length times width and substitute it in for the capital B for the area of our base, we get that the volume is equal to length times width times height. And now we can substitute these values in. We have 5 and 5/10 meters times 2 and 2/10 meters times 8 and 4/10 meters. And if we multiply these together, our volume will be 101 and 64 hundredths cubic meters. And the work shown on this slide gives us the same solution that we just calculated, that the volume of this rectangular prism is calculated by multiplying the area of the base times the height, or length times width times height, which would give us 101 and 64 hundredths cubic meters. Find the volume of the cylinder. Use 3 and 14 hundredths as the value of pi. Well, we know that the volume of any prism or cylinder is area of the base times the height. Well, because our base is a circle, the area of that base is equal to pi times the radius squared. So the volume of any cylinder will be calculated using the formula pi times the radius squared times the height. Well, we know that our radius of this cylinder is 9 and 2/10, and we're going to square that, And it says in the problem to use 3 and 14/100ths, so we're going to put 3 and 14/100ths in for pi. And then our height is 10.5 yards. So then if we multiply these values together, 3 and 14/100ths times 9 and 2/10ths squared times 10.5, we will get 2,790, and let's round to the nearest hundredth, 58/100ths. And our units are cubic yards. What we can see is the solution to our problem when we substitute 3 and 14/100ths in for pi as the instructions tell us, 9 and 2/10ths as the radius squared times the height of 10.5 yards. When we multiply those together, we do end up getting that the volume is 2,790 and 58/100ths cubic yards. A cylinder with a radius measuring 2 centimeters and a height of 5 centimeters is compared to a cylinder with a radius of 4 centimeters and a height of 5 centimeters. Amy says that the volume of the cylinder with a radius of 4 centimeters is double the volume of the cylinder with a radius of 2 centimeters. She used 3 and 14/100ths as her value of pi. Is she correct? Explain your reasoning. Well, let's start by drawing a picture here. So we have one cylinder. Its radius is 2 centimeters and its height is 5 centimeters. Now the other one, it's wider. It has a radius of 4 centimeters, but the same height of 5 centimeters. And she's saying that the volume is going to double. Let's calculate the volume of both of these to see if that's the case. So we know that the volume is equal to pi, and she used 3 and 14/100ths as her value of pi, times 2 squared times 5. And then in the other one, we have that the volume is 3 and 14/100ths times 4 squared times 5. So we know 2 squared is 4, and 4 times 5 is 20. 20 times 3 and 14/100ths will be 62 and 8/10ths. And this will be cubic centimeters. Okay, so now we're going to have 4 squared is 16. 16 times 5 is 80. 80 times 3 and 14/100ths. 80 times 3 and 14/100ths is 251 and 2/10ths cubic centimeters. And this should have been cubic centimeters over here. Now if we compare these, is 251 and 2/10ths twice or double the size of 62 and 8/10ths? The answer here is no. If we divide 251 and 2/10ths by 62 and 8/10ths, we're going to get 4 as our answer. So the answer to this question is no. When the radius doubled, the volume quadrupled. And the reason why it quadrupled is because in the volume formula, the radius that doubled, it was multiplied an extra time, and 2 times 2 is 4, so it's going to quadruple instead of double. And on this slide, it shows the solution to our problem, and we did calculate that the volume is 62 8/10 cubic centimeters for the smaller cylinder, and the volume of the larger cylinder, whose radius doubled, is 251 2/10 cubic centimeters. And when we divide 251 2/10 by 62 8/10, we end up getting 4 instead of 2. So no, Amy is not correct. If the radius of the cylinder doubles, the volume doesn't double. Instead, it quadruples.